Experiment 8 Cathode ray oscilloscope and AC circuits.
Now, we will measure DC voltage using the oscilloscope. The DC voltage is supplied through the power supply. Set a multimeter to DC voltage measurement range. Then connect the multimeter directly to the power supply. The positive probe of the multimeter is connected to the positive terminal of the power supply. The negative probe of the multimeter is connected to the negative terminal of the power supply. Turn on the power supply and set the voltage to 1 volt. Check the voltage from the power supply using the multimeter. Record your reading in table 5.1. Now, we will use the oscilloscope to measure this DC voltage from the power supply. First, connect a probe to channel 1 of the oscilloscope. Then turn on the oscilloscope, select channel 1, set the time per division to 0.5 millisecond per division, select auto triggering mode, and obtain a straight line on the screen. Place the input coupling in the ground position. Select channel 1 volts per division to 0.5 volts per division. Check that the vernier is in the calibrated position or your measurement will not be accurate. Use the vertical position control to place the ground reference level on the convenient reticule line near the bottom of the screen. With the multimeter still connected, place the oscilloscope probe at the positive terminal of the power supply. Place the oscilloscope ground clip at the negative terminal of the power supply. Move the vertical coupling to the DC position. The line should jump up by 2 divisions. Record this deflection in table 5.1. Repeat this experiment with different voltage setting. When you have completed measuring DC voltage, we will measure AC voltage using the oscilloscope. The AC voltage is supplied from the signal generator. Now, set a multimeter to AC voltage measurement range. Then, connect the multimeter directly to the signal generator. Switch on the signal generator. Select AC sinusoidal waveform with a frequency of 500 Hz. The frequency is adjustable by turning the knob here. Then, adjust the amplitude for 1 volt RMS by turning the knob of amplitude at the signal generator. 1 volt RMS can be read from your multimeter. As for the oscilloscope, we shall be using channel 2 to measure our AC voltage. Connect an oscilloscope probe to channel 2 and keep the time per division at 0.5 millisecond per division. Set the volts per division control, this time at channel 2, to 0.5 volt per division. Select channel 2 at the vertical mode control and also at the trigger source control. Now, connect the oscilloscope probe to the positive terminal of the signal generator. Connect the oscilloscope ground clip to the negative terminal of the signal generator. The input coupling switch should be in the DC position. Adjust the vertical control position and the level control for a stable display at the screen. You should observe approximately 2.5 cycle of AC waveform and a peak-to-peak value of 2.8 volts. This represents 1 volt RMS as shown in the multimeter. Record all your observations and your measurement in table 5.2. Repeat the AC voltage measurement using different AC voltage setting as outlined in Table 5.2. The different AC voltage setting can be obtained by turning the amplitude knob at the signal generator. Finally, you will observe the effect of the AC, ground, DC input coupling switch. With the switch still in DC position, we add some DC offset by pulling the knob and turning it at the signal generator. We can observe that the signal can be displaced from its original position because we are adding or subtracting a DC voltage to the signal. While you are observing the waveform, change the input coupling switch to AC position and turn the offset knob again. Describe how this control affects the input signal. Sine wave measurement. For sine wave measurement, we need a signal generator which is connected directly to the oscilloscope. Set the signal generator for sine wave at a frequency of 1.25 kHz. Set the signal generator for 1 volt peak to peak. Then set the oscilloscope time per division to 0.1 millisecond per division in order to show one complete cycle across the screen. The expected time for one complete cycle is the reciprocal of 1.25 kHz, which is 0.8 millisecond. With time division control at 0.1 millisecond per division, one cycle will require 8 divisions across the screen. Note this as your observation in Table 5.3. Now, change the signal generator to each frequency listed in Table 5.3. The frequency can be changed by turning the knob here. Adjust the time per division control to show about 1 to 2 cycles across the screen for each frequency. Complete Table 5.3 by computing the expected period and then measuring the period with the oscilloscope. Two-channel difference technique for ungrounded component voltage measurement. For this experiment, we'll need an oscilloscope with 2 probes, a signal generator, a breadboard, a 2.7 kilo ohm resistor, and a 6.8 kilo ohm resistors. Connect the apparatus as shown in circuit 5.4b. Use the 2.7 kilo ohm resistor as R1 and the 6.8 kilo ohm resistor as R2. Set the signal generator for a sine wave at 10 kHz. The output of the signal generator is connected across R1 and R2. Similarly, the oscilloscope probe of channel 1 is connected across R1 and R2. Therefore, channel 1 will show the output voltage of the signal generator. Make sure that the trigger source control is selected at channel 1. Now, we need to set the voltage from the signal generator to 1 volt peak to peak as shown from the oscilloscope. This is done by turning the amplitude knob of the signal generator. You may need to pull out the knob to get smaller voltage changes. Channel 2 is connected across R2. Therefore, channel 2 will show the voltage across R2. We can see the voltage across R2 by selecting channel 2. If you would like to observe both waveforms on the screen, we can choose dual. You can see the voltage across channel 1 and voltage across channel 2 on the screen. To obtain voltage across R1, we need to use the difference function between channel 1 and 2. This is done by first adding the two channels and then inverting channel 2. The voltage you obtain on the screen now is the voltage across R1. Record this measurement in table 5.4 and then use voltage divider rule to check that this measured voltage are reasonable.